Yeah, my name is Edwin Etheridge. I was a research scientist at NASA for 35 years in microgravity materials science. And the last 5 or 6 years, I was working on in-space resources, which was what I originally went to NASA to do. And in particular, extracting water from planetary surfaces, but specifically using microwaves to extract water from planetary surfaces. And when I retired NASA, I founded Space Resources Extraction Technology, and we are a space water mining company. The big problem is the extremely high cost of space launches. Our solution is to reduce the weight of expendables that have to be launched from Earth by using in-space resources, in particular water. With water, if you have water and oxygen, you can use it at lunar outposts. And you can also make in-space rocket propellant. Back in 2009, NASA sent a probe that crashed into the south pole of the moon. And they proved that there were billions of tons of water in the permafrost at the poles. Water is the low-hanging fruit of in-space resources. There's currently a market for water in space. The International Space Station requires the resupply of water by companies like SpaceX. It costs $5,000 a pound to take that water to the space station. That's $60 million a year. Another company, with their own money, they built an apparatus that would process the wastewater stream on the space station. And they sold that water back to NASA for $65 million over 6 years. In the near future, we're going to be going back to the moon. We don't think about it because we don't hear about it. But many countries on Earth are talking about human outposts on the moon. There are at least 4 partnerships between different nations to put outposts. On the moon, this same pound of water would cost perhaps $500,000 to get it there. That's $1 billion per year market. Man, if you go to Mars, my gosh, you need 200 tons of in-space propellant, rocket propellant, to get there. And the cost of landing water on Mars is prohibitive. So they will have to use in-situ resources. NASA this summer will be proposing a lunar water prospector mission. It's a little bitty rover that has a drilling apparatus that will drill 3 feet down. It will grab some soil, bring it up, cook it in a furnace to demonstrate that there is water in the soil. We have traction with NASA because we have SBIR funding, and we're using our patent-pending technology by microwaving down a borehole to extract the water and measure how much water we can get out, but just by using microwaves rather than extracting the soil. A couple of years later, NASA is planning a water mining demonstration mission. And they want to take an excavator that's going to dig the soil. They may have to dig 3 feet down to get to where the water is. But they have to have a sort of a massive excavator piece of equipment. Our technology is disruptive because we don't need these excavators. We can have something like a riding lawnmower that can drill a hole, put the microwave probe down there, heat the soil, it heats a larger and larger volume of time, and the water vapor will come up and we can collect it. We don't need this heavy mining excavation equipment. Our value statement is we can save the extremely high costs of putting this heavy equipment on the moon. We could perhaps save hundreds of millions of dollars by not having to deliver the excavation equipment. We have 2 distinct sequential market segments. In the beginning are NASA contracts. And then at the end, there would be hopefully a public-private partnership type arrangements where NASA would fund at milestones, much like the SpaceX contracts. Estimates of the financial projections, it's going to rise very quickly because space projects are very expensive at the end when you're developing space hardware. And I put in a 10% profit, which is nominal. After that, we would get to the point to where we could then be doing demonstration extraction of water and then selling back to NASA. And that's where you have the humongous sales and humongous profit margin. We are asking for $43,000. A critical milestone I have to get across is I have to develop a small, high-efficiency, low-weight microwave amplifier to run my microwave system. I want to have one that's small enough to fit inside of a CubeSat satellite that students are putting in orbit right now. I want to team with a university to build a CubeSat and do a demonstration water extraction experiment in orbit. Now that's not the moon, but I can simulate an asteroid and extract water from a simulated asteroid. Then once we've proven the technology, then we can go through the expense of landing the payload on the moon at $5 million a kilogram and get traction with the investors out in the new space world out in California, get better traction with NASA. If we've demonstrated we can build the hardware, the microwave amplifier and the like, we'll have better traction with both NASA and with the new space industry. My team, we've all got over 30 years of experience in our fields. I supported 12 space missions. I've been an entrepreneur my whole life. Ben Lowe is a very good, excellent microwave engineer. He's developed microwave hardware. He's even built microwave amplifiers. And Bill Conkler is my collaborator. He's worked with me for over 30 years, and he's a co-inventor of the technology. And I'd like to thank Alabama Launchpad for the opportunity to present.
Thank you.